Hey guys, Raz here, and we're going to be doing some radians on this beautiful summer's day. Nothing better than doing maths on a summer's day, eh? Love it. So, radians, let's define what radian is first. So, a radian is the angle created when we divide the arc length by the radius. By definition, one radian is the angle subtended when the radius and the arc are the same length. So, let me jig these around because really the one in white is the one that's more important. So, what I'm saying there is if the radius and the arc length are the same, so if this length here happens to be equal to the radius, then this angle created is called 1 radian. Yeah, so let's compare this to degrees. Yeah, so it'd be interesting to know how many radians there are in a full circle. So to do this, let us consider the radius as 1. And therefore the arc length will also be 1. Yeah, so those three lengths are equal. That's supposed to be a 1. So we know circumference of circle is equal to 2 pi r. And we know the radius is 1 in this case, so the circumference is 2 pi. Yeah, therefore, there must also be 2 pi radians in the full rotation. Therefore, so the number of radians, which we use as a little c as a notation, in a full rotation must be 2 pi times the 1 degrees that we had, which is 2 pi radians. So therefore, 2 pi radians is equal to 360 degrees. And that is an important conversion that we'll be using all the time, yeah? So furthermore, we could say that, one very good. Sorry if I forget to edit this mumbling around. So, since 2 pi radians equals 360 degrees, it follows that pi radians must be 180. Pi over 2 would be 90, and so on. Yeah? So typically, we wanted to convert 42 degrees into radians. We would do 42 over 360 to see what proportion of a full circle it is, then times that by 2 pi. If we wanted to convert radians into degrees, we'd do the same thing. So say we had 1.1 radian. We'd see what proportion of a full circle that is, and then multiply it by 360. Yeah? Make sense? Excellent. So let's extend that and derive the formula for arc length and area of a circle using radians. So I encourage you to pause the video and give this a go. Welcome back. So we know that the area of a circle that we're familiar with is pi r squared. And we know that the arc length of a circle is a proportion of the diameter. So we have a proportion of the diameter and a proportion of a full circle for the area of the sector. Sorry, let me just correct that. Got what I was doing for a minute. Theta over 360 times pi r squared. And that gives us the area of the sector. So we need to just manipulate our fact that we know 360 degrees is 2 pi. So if we simplify that to this, we can see straight away that the pi cancels and we're left with the area of the sector is equal to a half r squared theta. We do the same for the arc length. We know that their 2 pi radians is 360 degrees. This time, both the 2 pi's cancel, and we get that the arc is equal to r theta. Yeah, I'm not sure why I wrote theta r squared, then wrote r squared theta or theta r and an r theta. It's just the way we remember them, really. So these are two key formulae that we'll use for radians, and we use these when we're trying to find the area of the sector or the arc length, because it's easier, yeah? Obviously, your angle must be in radians, not degrees. Otherwise, you'll be in all sorts of bother. So let's practice a couple of questions on that. I think that's all we've really got those ones to do. So pause the video and give those a go. Welcome back. So let's give myself a little something to write on. So in the first one, we're told an arc, AB of a circle with radius 7 and centre has a length of 2.45. Find the angle subtended by the arc. So we know arc length equals r theta, and we know 2.45 equals 7 times theta. And we just want to find what theta is. Therefore, theta is 2.45 over 7, which will equal... No, didn't think about that one, did I? Let me move my calculator. Let's do that. And do that. So we want 2.45 divided by 7. And we get 0.35 radians. So 7 over 20, which is 0.35 radians. And that's it, because now when we're dealing in radians, 2 pi is the amount of degrees in a full rotation. So instead of being out of 360, the scale's suddenly out of about 6, isn't it? So numbers are all going to get a lot smaller now. Now let's try the next one. This time we're told the perimeter is P. Express R in terms of P and theta. So an arc AB of a circle with centre R and radius R subtends at an angle of theta radians. The perimeter is P. Express R in terms of P and theta. So the perimeter will be of a sector is going to be, and that's the arc plus 2p. And we know the arc is equal to r theta. And then we just add 2p to it. Done. Well, kind of. I kind of just totally misread the question. So the perimeter sector is P. That's right. So express R in terms of, I've just done it the wrong way around, haven't I? Hopefully a load of you have realised that. Let's get rid of this garbage. There's a 2R there. So P equals R theta plus 2R. Job done. And the final question, for those of you that are still here, pause it and give it a go. Welcome back. So, find the length of C. So we want to find the length of the major arc, not the minor arc. So we can easily figure out this angle here by using cosine rule. So we know cos A equals B squared plus C squared minus A squared all over 2BC. And we want to do cos inverse of that, or arc cos of that. And that will give us that minor angle in radians. This is the first time we need to be careful about how we use our calculator. So I actually got access to it now. So watch this. I'm going to go to setup. Make it look so easy, don't I? I'm going to go to shift setup there. Angle unit. Radians. Job done. So now when I put this answer in, B squared plus C squared minus A squared. So we have A will be 2.4. So I've got 2 squared plus 2 squared minus 2.4 squared all over 2BC. 2 times 2 times 2 equals that. Now arc cos answer 1.287 radians. So if I put that in degrees, that would not have helped. But we actually want this angle. So theta is 2 pi minus that. And that's what we need to remember. So 2 pi minus the answer is 4.996. I'll write a few decimals in because I don't want rounding error. Ain't about that life. So now the question is, find the curved part of the circle. That's just the arc length, isn't it? So the arc equals r theta. The radius is clearly 2. So I just need to double my answer. And I'm not going to get any rounding error because I haven't rounded yet on my calculator. So we got 9.99 is the length in meters. Yes, I hope that you've enjoyed that video. I know some for me might not be for you when you're watching this. See you again soon.